Hello. Can you hear me well? Thank you. Thank you for the kind introduction, and thank you for the invitation to this beautiful place and the exciting exhibition. And thank you for the invitation to be able to talk here about surveillance and the use of patterns and of big data by those who do the surveillance. The surveillance is being used to protect us, they say. It's used by police and by intelligence services to increase everybody's security. We hear again and again that we'll have to give up a little bit of our freedom, of our fundamental and civil rights in order to get more security. This raises questions, though. Whose security is being protected? Why, for example, aren't women being protected from domestic violence with the same efforts that we see again and again when security laws are being tightened because of terrorism, Islamism, or migrants? A lot more people die in traffic accidents than die in terrorist attacks here in Europe. Why is security not to die in a car crash not as valuable? Why don't we put as much energy into that kind of protection? What about the security to have a job, no climate warming, a place to live that we can afford? I think, and that's quite obvious, surveillance doesn't only have security as a reason, it also has the reason that police and intelligence and states in general like to have some control. They like to collect data, and they have an urgent need to control us. Allow me to lead you through a short history of surveillance and pattern recognition from the 20th century until today. And if we have time, it would be nice to discuss what the future might bring apart from artificial intelligence. In the 1880s, a guy called Hollerith invented punch cards. He was an employee at the US Census Bureau, and what he invented was readable cards with a standardized perforation, which each represented specific characteristics such as gender, nationality, and occupation, so as to make it easier to actually count and know who the population were and what their characteristics were. His company was later sold to what was to become IBM, a company still known today and quite famous. And IBM then collaborated with Germany, which became a fascist early in 1933, and already in April of 1933, Germany announced plans also to have a census to know more about its population. And with the help of the punch card systems that was invented by Hollerith, for example, it was much easier for the Nazis to understand who the Jews were, where the Romani people were living, and a lot more about the different groups of society. The punch card system was later used widely by the Nazis. There was actually a Hollerith department in each concentration camp, and IBM profited largely from this collaboration. So this was sort of the first known instance of pattern recognition and machine and tech-supported surveillance and control of population that we know. I would like to move on then to something that was started after the Second World War. What's called the Dragnet Investigation. You probably have heard of this system as well. It was invented in Germany in the 1970s as part of the anti-terror investigations by the then head of the Federal Police of Germany, who had to deal with left-wing terrorism, which was happening in Germany like it was in many other European countries. and specifically was used to find the kidnappers of bankers and of politicians when they tried to figure out who was actually doing these kidnappings and how to find them. And instead of doing what we would consider normal police work and like following leads and trying to understand who the criminals were, they invented this Dragnet system, and in fact it was sort of a negative Dragnet system, meaning that they collected huge amounts of data and then came up with specific criteria and looked for the people who actually did not match these criteria. For example, what was specifically done in the first case that we know is that they were looking for people who were living in a specific area and who actually paid their rent in cash and did not use bank transfers. So they, first of all, looked at all the people living in the area, and then they had saw who are the people who don't pay in cash, and then also matched some other criteria, and actually broke it down to 2 people, one of which actually was one of the terrorists who had captured one of the bankers that they were actually looking for. So you could say, well, that worked quite well. It was a well-functioning system. It's interesting to know, though, that what had been overseen before was that an ordinary local policeman had already noticed that specific apartment that they were looking for and had already actually told his leading police forces about this, but that information had gotten lost in between. And so you could also say ordinary police work is increasingly being underestimated with the increasing use of technology to replace that ordinary police work. There's a similar reasoning that we see with the Dragnet investigations, for example, also, and there it becomes a bit more questionable, or obviously questionable, when you look at the reasoning behind racial profiling, for example. It's black people who sell drugs or carry guns, and so, or in the perception of the police, I need to add that they are mostly looking for black people carrying guns, and therefore mostly black people are being controlled. So already the criteria are defined beforehand, and then only these people are being controlled. It's kind of a self-fulfilling prophecy, if you like. If more black people are being controlled because of the racist bias, then that's also going to be one of the main criteria of the Dragnet, and then the other people who are maybe also carrying guns aren't actually being controlled, and so on. I think you get the idea. I would then move on to a system that was invented at the end of the Cold War by what we call the Five Eyes, which is the intelligence services of the United States, Canada, Great Britain, Australia, and New Zealand. And the system that they invented was called Echelon. And what they did was do a mass interception of satellite communications data and trying to actually search for specific terms in the communications data. I think the ones of us who are a bit older probably remember the jokes that we made in the end of the 90s about how you were not supposed to write the word bomb in your email anymore, because that would set off this system that was looking for the search terms and then actually start looking at who you are. And we were making jokes about this, and we didn't really seriously think this was actually going to happen, because well, some of us maybe, but most, I think, just were joking about it, just like we're joking today about the mass surveillance that we later heard from Edward Snowden. And it's so hard to imagine that, because there's so many people using these terms and using these kinds of communication, that it's really hard to imagine that this was actually lead to sort of increased targeted surveillance upon you. But this system was sort of the offspring of that type of massive data interception and mass surveillance. It was started again. The first ideas were invented in 1990, right after the Cold War, and the primary goal of Echelon was economic espionage, really, to understand what the competing countries were doing. And one of the stations for intercepting satellite communication. You can see in this image, it's actually in Bavaria. It's in Bad Aibling near Munich, which used to be a U.S. military station that was there after the Second World War and stayed in a U.S. military site until much, much later. And these satellite interception dishes are actually still there today. Of course, Echelon, as it was an operation between intelligence services, it was completely secret and nobody knew about it, especially also the parliaments and the democratic oversight didn't know much about it, but eventually more about it became known, and so the European Parliament started an investigation about what Echelon actually were. And it was sort of difficult to find out. There was rumor and there was a lot of debate at the time, and pretty much exactly when the EU finished its report about Echelon and was ready to talk about what was really going on, 9/11 happened in 2001. And I'm warning against seeing this as a conspiracy. I think that would go really too far, that 9/11 would be there's people who define that as a cover-up of the Echelon scandal. I don't think that is what happened, but it's really a huge coincidence that this was happening at the same time, and through when 9/11 had happened, nobody talked about Echelon any longer. What happened then, and here you see a German poster that I'm going to explain to you in a little bit. What happened then, as one of the aftermaths of 9/11, when most European and America, of course as well, European countries increased and tightened the security laws in order to fight terrorism, is something that became known as data retention. The EU created the so-called Data Detention Directive in 2006, meaning that all telecommunications providers would have to store the metadata of telecommunication for a specific amount of time, between 6 months and 2 years. So you can see in the first line, that's the 2006 was the EU directive saying data need to be retained, and only the metadata, not the content of the data, so not what you are actually writing in your email, but who is sending something to whom, at what time, using what device, etc. And so the German government, and I couldn't find a better poster for this in English, I'm sorry, so I'll explain it to you. So the German government in 2007 said, oh, that's interesting, let's have data retention maybe. And instantly several people went to the Constitutional Court and said, well, we don't think it's okay to actually surveil the whole population and store everybody's data just in case you find some terrorist with that. So that went to the Constitutional Court, and in 2010 the German Constitutional Court said, no, this actually is going way too far, and it's endangering privacy, and you cannot just store everybody's communications data. The European Court in 2014 decided also that the German law for data retention was not legal, and in different European countries there's different ways of actually making national law out of the EU directive, so there are different forms of data retention. What's interesting in Germany, I find, is that the German government in 2015 again tried to do another law on data retention. Basically what we see happening is that police, secret services, the governments in general keep wanting to do more intense security laws, collecting more data about people, completely neglecting fundamental or civil rights or the right to privacy, to free speech, etc. And what is happening in different countries and in the European level as well is that then the constitutional courts at some point say, well, no, but there is also the right to privacy and there is the right to informational self-determination. This is not going well everywhere, but it's sort of like the same dynamic. The countries go too far and then they're being pushed back a little, and then they go further, always with the intent to collect more information and more metadata as well. And so this goes on. And the interesting thing about this is that specifically about the data retention, it was argued many, many times that we didn't worry about it because the content of the communication, the content of our phone calls, the content of our email wasn't being looked at all. It wasn't being stored. So this was only about the metadata, and I remember vividly lots of politicians explained to us that there is no problem at all because it's not about the content of what we're saying. Nobody is reading that. But then, much later in 2014, Michael Hayden, who used to be the director of both the CIA and the NSA, and then later also the director of national intelligence, which is sort of the super leader of all intelligence services in the US, after Snowden, at some point on a TV show, openly said, we kill people based on metadata alone. We don't need the content for that. Actually, the metadata is much more interesting. And why is that? Because that can be used for pattern recognition and to actually see a lot more than by... And actually, it's easier to detect because you can use machines to actually form or pull information out of who talks to whom when and who moves where and who knows whom rather than what they're actually talking about. And what he meant when he said we kill people based on metadata is the US drone war, right? The US and specifically the CIA is leading a drone war in Pakistan, amongst other countries, since 2004. It's a non-declared war, but there's a lot of people who are being killed by this. The way this works is the drones have cameras and they film, and then eventually there's people elsewhere who decide which people are going to be killed, which people are perceived to be the terrorists. I'm sure that the basic phenomenon of this is known to many of you. This is one of those lethal drones this is an unmanned aerial system, as they are called, that is flying in Pakistan and actually used to kill people. And what we know now, because it was exposed also by Edward Snowden, but only published actually much later in 2015, is a system called Skynet, and there were these are slides that were, I think, I'm not sure if it was the first batch of information that was exposed by Snowden, but there was only publications about it when the Snowden scandal sort of slowed down a little bit. And the system called Skynet is basically using metadata to understand, and it was being used to understand who the careers for Al-Qaeda in Pakistan were, and they were originally what was being done is that all of the mobile communication in Pakistan and Afghanistan is being intercepted by the US, and of course analyzed, and they were in the beginning, and I'm sure this is still happening today, looking for specific, for example, mobile device identification, both the devices but also phone numbers, because they knew through human intelligence, for example, who they were actually looking for, what phones that they were using, or because they had questioned prisoners about these types of things. So it's sort of like what you would consider old-fashioned regular intelligence work. But what they were then turning to is machine learning through intercepting lots of metadata. And like I said, in Pakistan, all of the mobile communication is being intercepted, and then looking for patterns and looking for irregularities, defining criteria, how, for example, couriers contacting Al-Qaeda would behave, where they would move, and how this is different from normal population in Pakistan, and then defining who actually their targets are, and actually defining also what their drone targets were. And they're actually saying these. There's a bunch of slides that I'm not all going to show to you now. It's actually quite interesting how openly, I mean, it's not open, it's top secret, right? So this was not meant to be public, but how they are using machine learning actually to define who is going to be killed. one famous person that they actually considered to be one of their targets is this guy, Ahmed Zidane, who they defined as having a high score of being one of those couriers traveling to Al-Qaeda who they wanted to find. And what's actually said in this slide, which is what's true, which is like at the bottom line, he works for Al Jazeera. He is not an Al-Qaeda courier, he is a journalist. He's working until today as a journalist. He survived, luckily. Yeah, you can see here how they sort of calculated for him to be a terrorist and to be executed. What they are using also, and this is a slide that is also from the Snowden revelations, but related to something different, which is the, sort of the selector system that is being used to understand about intercepted communications data. And there was a lot of more publications about this issue. Basically, what's happening is that communications data are intercepted, and now I'm not talking about Pakistan, Afghanistan, or not only about Pakistan, Afghanistan, but also about international general communications data. We know this because the German parliament has had an intense inquiry also about how what Snowden revealed actually played out in Germany, how the German intelligence services are cooperating with the Five Eyes, and exactly how technically this cooperation is being done. And through this and the Snowden revelations, we know that a lot of both satellite communications data, but also the communication that's happening through the fiber optic cables, is being intercepted as basically as much as they can get. And then they have specifically defined selectors, which means basically something like search terms where there's both phone numbers, email addresses, device IDs, and all the things that you can see in this slide that can be a selector that helps for example, the NSA or any other intelligence service that cooperates with them to find the people who they are looking for. We know that in 2015, in Germany alone, 14 million of these NSA selectors were being used. And they describe about 1.2 million people or companies that were being looked for. And what I've found very interesting when we were discussing this with the German intelligence service in the inquiry is that they kept pointing out that we were trying to prove that there was something like illegal mass surveillance happening with the cooperation of the German Secret Service, but this was not the case, they argued, because what they were doing was targeted surveillance, because through these selectors they were looking for specific targets. And then we said, yeah, but do you have 1.2 million targets? I mean, is that actually targeted surveillance, or shouldn't that actually be considered to be mass surveillance? And that sort of started to become something like a semantic debate over what is mass and what is targeted and what is legitimate to fight terrorism and what isn't. That conflict still exists. There is just simply different views about this. And then I'm moving on to the next system that's being used in pattern recognition. This is one example. That's an image of software that is being used for what's called predictive policing. Basically, where the police are collecting huge amounts of data, trying to understand what type of criminality is happening where and by whom, and then sort of doing a lot more police control or actually like just being there waiting for specific types of criminality to happen, because it's sort of being calculated who and where would be doing this type of criminality. This is the first start of this sort of prediction software was started in 2010 in California. And what we're seeing here is what's called the Amsterdam Crime Anticipation System. When these systems are being used, often the population extremely uneasy about it, because the idea that there would be police by engineering whether you might become a criminal or not, and therefore even because since you haven't done anything, still probably arresting you because you might do something, is something that populations in general feel very uncomfortable about for very good reasons. And so the way how this is being described to the public to make them more at ease with these systems being in use is that it's being used for the prevention of break and enters, for example, and for traffic control, basically to find out where most traffic violations would be, which is something that is much more tolerated by many people, rather than understanding that your data, your life basically is being in a sort of surveillance that might end up you just being the object of some calculation that you don't understand, that sort of defines whether you might become a criminal or not, and where that actually might lead to. There are studies that find that predictive policing software doesn't actually improve the crime rate much. That doesn't change most police and law enforcement in general wanting to have that kind of software. It generally leads to to have less people but more machines doing the police work, and since there is less police people in the street, there is also an increasing, or it's described, there is a public debate about this uneasiness of having less security in the street, and that is sort of being compensated by the use of software and machines. One of the problems that comes with that is of course that when you have like these red dots as being areas where there would be maybe more crime, that leads to more police being in these areas, with the effect that there is less police in others, which of course both could lead to increased crime in those areas that are being policed less, but also probably in a feeling of feeling less secure by the people who live there. That depends on how that's being communicated, of course. And when you look at how the software is being done, then you run into some kind of problem that deals with the fact that, of course, the software can only include into its calculation the crime that is being reported, meaning that crime that is not being reported for one reason or another is not being included in the overall calculation. And what's also an interesting aspect with this specific system is that, of course, it's, for example, not being used to detect something like tax fraud, for example. And you could ask, why aren't we designing software that makes it easier, for example, to find this type of white-collar crime, right? That is, like, I haven't heard of systems that are getting an equal amount of money and an equal amount of interest by law enforcement for that kind of crime. It's not being discussed at all. And then that leads a bit to the topic of the symposium, because, of course, with these latest, the last examples, machine learning comes into that, and artificial intelligence plays a role. It seems that, and the topic of the symposium sort of shows that as well, but in a different way, that everything seems to be about artificial intelligence at the moment. And people that I'm usually around, and I think that is true for probably many others as well, don't really know what artificial intelligence can do. We all have this uneasy feeling that there will be machines sort of becoming more intelligent than us. And already the term, and that's been said before, is sort of misleading a little bit. It sort of implies that the machines will become intelligent instead of thinking of it as machines gathering intelligence, right? Gathering information and then doing something with that. And where is sort of the line between one intelligence and the other? But however, it's really scary to most people to think that they might take over in some way or another because of machines being under control, but also less scary maybe, but scary enough, the idea that machines will be taking over many of our jobs. because we won't be needed so much anymore, and there's much less talk about how we are going to make money in the future if there's machines taking over what we're actually doing. I think it's, however, when you talk about the scare of artificial intelligence, it's better to talk about machine learning and then to look at what they are actually learning. I think that's an interesting part in here, and we've heard this before, that machines learn from the data that already exist, and this is how they create the intelligence that they have and that they work with. And this data reflects what we are and how our societies are. It's not a neutral type of data, but it reflects exactly the stereotypes and the biases that already exist, and that's what the machines are learning. They will not be different. They do reflect the unethical aspects of society. If the society is racist, then the machines will learn to be racist as well. They learn to be sexist, homophobic, etc. That's also, that's also why, for example, facial detection software that's created in the Silicon Valley is not as good with faces of non-white people as it is with faces of white people, because they learn with white faces, and that's what they are really good at detecting. Same with, for example, irregular appearances because of specific health issues. And then you could say, well, that's, of course, then that's one nice thing, that the facial detection software doesn't detect everyone as well as they detect the white faces. But then I think the downside of that is that's like, I think that the one general aspect that needs, there is a lot of discussion, but I think still needs a lot more discussion, that AI is very good at finding out and learning what the average, what the norm is, but it's actually not good at learning what everybody else or what everything else is that is not sort of the standard. And that means that the use of AI then leads to sanctions for those who are different, and that will result in all of us trying to not to be different, right? So it will sort of lead to a standardization of what we are and what we do and how we think, because we will try not to be the other that is being singled out by artificial intelligence, I think. And that's important to consider and to talk about more, because being different is one of the core aspects of democracy. And then that sort of starts to be forgotten every now and then. Democracy needs difference, it needs arguments, it needs debate. One of the core aspects of democracy is also free speech, the right to actually say what you think and to express yourself in any way that you like, and it's one of the fundamental rights, and I think that's sort of being forgotten a little bit or it's not forgotten, but it's being neglected more and more when we are turning more towards machines that are sort of pushing us to align and to behave the same. Already Foucault found out that, and that leads back to surveillance a little bit, found out that when we feel that we are being watched, we change our behavior, not because we fear, not by being sanctioned for that, but already being watched changes our behavior. There's even like the effect that if you're alone in a room and there's an image of someone watching you, people start changing their behavior, because being by yourself and not being watched, and I think we all know that, gives us a specific freedom to be and to explore that we don't have when someone is around us. And if this is disappearing because we fear negative consequences, I think our democracies will slowly disappear as well. And in my view, it doesn't make a lot of sense to discuss about ethical algorithms so much, and that's a discussion that's happening in Germany intensively right now, how algorithms need to be ethical somehow and need to be transparent somehow. I think the main topic of debate needs to be how the learning happens and what type of data is being used for the machine learning and what is being reflected in the data that is being given to the machines to learn from. And then we need to talk about the values that we want the machines to learn.